Converting and running basic analog multisim circuits in TINACloud. In this video, we'll show you how to open, convert and run circuit files created with Multisim v14.2 and its online version, Multisim Live, using TINACloud. This is especially important for Multisim Live users who wish to continue working online, as the Multisim Live simulator will be shut down on September 15, 2026. We'll focus on analog circuits in this tutorial, so be sure to check out our other videos for logic circuits and more advanced topics. With TINACloud, you can open and run both analog and digital Multisim Live files. Export from Multisim Live. Start with the circuit voltage divider in Multisim Live and click Open the circuit. You can verify the design by clicking the Run button to calculate the PR1 output voltage. Stop the simulation and navigate to the menu. Select Download to save the file to your computer. Import to TINACloud. Next, go to TINACloud and select Upload from the menu. TINACloud supports .ms14 and .ms13 from the offline version of Multisim, as well as .msjs, the Multisim Live format. Select this option and find the already downloaded voltage divider MSJS file. The converted circuit in TINACloud appears. Analyze your circuit. To see the result, press the DC button. Along with numerical analysis, Kina and TINACloud feature advanced capabilities such as symbolic analysis, a particularly powerful aid in teaching, as it brings to light the theoretical relationships that give meaning to the numerical values. To demonstrate this feature, open the Analysis menu, select Symbolic Analysis, and then choose Symbolic DC Result. TINACloud will return an analytical formula that yields the same result as the numerical analysis, but in closed form. Of course, symbolic analysis is not limited to simple circuits, it handles more complex ones just as well. To see this, select Current Source from the Sources component toolbar, rotate it by 180 degrees, add it to the circuit, and connect it in parallel with R2. Then perform a numerical analysis first, and repeat the calculation using symbolic analysis. To obtain the numerical result, press the DC button. To obtain the symbolic result, follow the same menu path as before. Analysis, Symbolic Analysis, Symbolic DC Result. The program returns the analytical formula, which produces the same result as the numerical calculation. Moreover, the formula clearly demonstrates the application of the superposition theorem, expressing the total response as the sum of the partial responses, due to the current source and the voltage source acting independently. This is what makes symbolic analysis such a valuable teaching tool. It exposes the inner structure of the calculation, which is otherwise lost in a purely numerical answer. Series RLC Circuit Analysis in TINACloud. We have already opened the circuit in Multisim Live and downloaded the file to our computer. After launching TINACloud, let's upload the file using the standard upload procedure. The schematic will appear maintaining the same layout and parameters as seen in Multisim Live. Numerical Analysis. Numerical analysis allows us to observe the circuit's behavior over time and frequency through data-driven simulations. Let's first run a transient analysis. To generate curves, run Transient Analysis via the Analysis menu, Transient. The curves will appear in a single shared diagram. The coordinate system magnifies the view between the minimum and maximum values. Round the axis scales for better readability. Click an axis to open the scale settings. Select the Round Axis Scale checkbox, then click OK. To view multiple curves simultaneously, go to the View menu and select Collect Curves. Enhance your results by adding a legend or individual labels to identify each curve. AC Analysis. Now let's run AC Analysis. Navigate to the Analysis menu, select AC Analysis, then click AC Transfer Characteristic. You can select several diagrams from the list. Select the amplitude and phase diagrams. A two-panel Bode diagram will appear. As with the transient analysis, you can round the axis scales for clarity. To perform other types of analysis, return to the Analysis menu and select AC Analysis, AC Transfer Characteristic. From there, you can choose Nyquist in the Analysis window to generate the diagram. To improve the resolution of the plot, increase the number of points and click Run. A Nyquist diagram appears. Adjust the axis scales as needed. Symbolic Analysis. Beyond numerical data, TINACloud can perform symbolic analysis to generate mathematical formulas that describe your circuit's behavior. Go to the Analysis menu, select Symbolic Analysis, then choose Symbolic AC Transfer. The transfer function will be displayed in its symbolic form, providing a direct analytical representation of the circuit's performance. The text editor allows you to embed the symbolic formula within the circuit design. Second-order low-pass filter analysis. For our third example, we will analyze a second-order low-pass filter. Follow the standard procedure to download the circuit file from Multisim Live and upload it to TINACloud. Transient analysis. First, let's perform a transient analysis. Navigate to the Analysis menu and select Transient. In the Settings window, set the end display time to 100 milliseconds and press Run. The results will display the output, PR1, alongside the excitation signal, V1. To view both signals in a single plot, go to View, Collect Curves. Using the virtual oscilloscope. To observe the signals in real time, we can use the built-in oscilloscope. Close the current diagram. Go to the TNM, Test and Measurement menu, and select Oscilloscope. Click Run and apply the following settings to clarify the signal. Set the time div to 20 milliseconds and the volts div to 5 volts. Adjust the time div to 5 milliseconds for a more detailed view. To stabilize the waveform, change the mode from auto to normal. Under the Source tab, select PR1 as the trigger signal. You can now synchronize using either the positive or negative slope. Once finished, stop the simulation and close the oscilloscope window. AC and Symbolic Analysis. Now let's examine the frequency response. Go to Analysis, AC Analysis, AC Transfer Characteristic. Both the amplitude and phase curves will appear. Transitioning to Symbolic Analysis. Because a standard op-amp is a nonlinear component, TINACloud must treat it as an ideal operational amplifier to generate a mathematical formula. Let's first recalculate the transfer characteristics numerically in a relevant voice frequency range. Run AC Transfer Characteristic again, specifically for the voice frequency range, 20 Hz to 20 kHz, with 100 points. The Bode plots, amplitude and phase are displayed. Now close the diagram and generate the formula. Go to Analysis, Symbolic Analysis, Symbolic AC Transfer. The symbolic transfer function appears. To add the resulting formula to your design, select the Send To tab and click Text Editor in the Results window. Check the text size, then click OK. The symbolic transfer function is now embedded in your schematic. Comparing ideal versus nonlinear models. Finally, we can verify the accuracy of the ideal model by comparing it to the nonlinear version. Open the interpreter and press Run. This draws the transfer function based on the ideal model. Overlay this plot onto the existing Bode diagram to compare it with the nonlinear model. Click the curve and select the Copy Curve icon to copy it to the clipboard. Next, switch to the AC Bode diagram tab, click on the plot area and select the Paste Curve icon. As you can see, the two curves match almost perfectly. The same is true for the phase characteristics, so let's perform that comparison as well. Again, the agreement between the results is good. However, at higher frequencies, the ideal op-amp shows deviations from the phase response of the more accurate nonlinear model. That brings us to the end of this tutorial on converting basic Multisim live circuits and running them in TINACloud. Be sure to check out our other videos on logic circuits and more advanced topics. For more information, visit our website at tinacloud.com. Visit our YouTube channel, youtube.com/TINA Design Suite.